Differential thermal analysis DTA. Differential thermal analysis measures the difference in temperature between the sample and reference material against time or temperature. So it is basically delta T versus T or small t. Delta T is change in temperature against temperature, or small t is time. And here the heat flow to the sample and the reference are the same. Now this is a plot of DTA. So it is nothing but change in temperature against, here it is temperature. So we can see a crest and a trough. Crest indicates, or this peak, it indicates exothermic change that happened, and a trough indicates, or this depression, it indicates a endothermic change that has happened. Exothermic means heat is liberated and endothermic means heat is absorbed and a reaction has taken place. Now we will first of all see what type of reactions can be exothermic and what type of reaction can be endothermic. As I said earlier, exothermic reactions are some reactions which liberate heat. Endothermic reactions are reactions which can be carried out by absorption of heat. So some of the examples are physical absorption is exothermic. Physisorption is exothermic, and crystal structure change is exothermic, crystallization is exothermic, oxidation is exothermic, chemisorption is also exothermic, and some kind of a breakdown reaction, it can be both endo or exothermic. Now what are the endothermic reaction? We can see all solid state reactions are can be like breakdown reaction. Solid state reaction can be endothermic or exothermic. Desorption is completely exclusively endothermic. Physisorption, and while physisorption and chemisorption are exothermic, desorption is endothermic. That is, we have to supply something for the desorption to take place. Melting is endothermic. We have to give heat, then only it can melt. Reduction is endothermic. We have to supply hydrogen, like that. Some energy must be given. So then only reduction will take place. While oxidation, when it happens, it liberates energy. While reduction happens by gaining energy. Vaporization is also endothermic. We have to heat, then only it will become vaporized. Sublimation is also endothermic. Now this is the instrumentation of a DTA. We can see a furnace which has two pan. Like a balance, it has a two pan. One of the pan is sample holder and another pan is reference. The reference will be usually alumina, which is thermally stable compound. And you have something called as flow control. Why means this furnace is filled with inert gas like argon or helium, because it has to be done in an inert atmosphere, which should not interfere with the substance that is undergoing heat change. Next we have the signal reader, DC amplifier, and a recorder we have. This is the instrumentation of a DTA. So we will see elaborately. So sample holder, thermocouples, this is the main thing in this DTA. Next. And as I told you, the reference mostly it will be alumina, and generally helium and argon inert gas is used in the system. Now we will see first of all the basic difference between thermogravimetric analysis and differential thermal analysis. So in thermogravimetry, the weight loss or weight gain is measured as a function of temperature, while in differential thermal analysis, the temperature difference between the sample and the reference is measured as a function of temperature or time. Next difference is TGA can be used until like 1000, 1500, until that region only. While DTA is higher than TGA, usually it is higher than DTA. TGA 1600 like that. Next, TGA can be used for quantitative analysis. Now, how much quantity we can find out by measuring the loss of mass delta M. By measuring delta M, we can find out how much quantity of the substance weight loss had taken place. We can able to do the quantitative analysis. Here also, by measuring peak areas and peak height, we can do the quantitative analysis. Next difference is we can check the purity and composition of the material. We can find out the drying temperature, ignition temperature, and the thermal stability of a material by doing the TGA analysis. By doing the DTA analysis, we can know the transition temperature between different phases and specific heat of a reaction. For example, if it's undergoing oxidation reaction, reduction reaction, we can know the specific heat of a reaction, and the melting point of a substance also we can know by seeing the plot of DTA. Now this is, as I told you, this is the most important one of the most important the part of instrumentation of DTA, which is the thermocouple. So this only gives the temperature readout. As it is change in temperature against temperature is the analysis of differential thermal analysis. This thermocouple plays an important role in the DTA analysis. Thermocouple plays important role in TGA as well. So first of all, we will understand what is this thermocouple. It is nothing but it works on Seebeck principle. What is Seebeck principle is, when we have two dissimilar metal, I have given some example. There are some example for thermocouples: chromal aluminum thermocouple, copper constantan thermocouple, iron constantan thermocouple, nickel chromium thermocouple, platinum rhodium thermocouple. Likewise, platinum ruthenium thermocouple is also there. So in all the example we saw two metal which are dissimilar. They are not similar. Okay. So they are joined together, and when they are joined together, like how I gave in this diagram, you can have a junction for this two dissimilar metal, and if you give a heat or a cold treatment at this junction of the two dissimilar metals will generate a voltage, and that voltage will correspond to the temperature. With this Seebeck principle only, thermocouple is used in all these devices to give us the temperature readout. Now we will see the application of DTA. Some of it we saw in the differentiation between TGA and DTA itself. Once more we will see. It is widely used for studying and characterizing polymer materials, that is very high molecular weight materials. It is used in ceramic and metal industry. It is used to study the decomposition temperatures, phase transition, melting point, crystallization point, thermal stability also. It is used for the generation of phase diagram and also for the study of phase transition. Thank you.